Good afternoon. My lesson is on volcanic eruptions, and I want to start with giving a brief introduction on some history of volcanoes. Volcanology, or the study of volcanoes, is something that dates back to 79 AD when Pliny the Younger gave a description of the eruption of Mount Vesuvius. Today, volcanoes like Yellowstone Park and the Hawaiian Islands could be used as a testament of what is happening in Earth's interior if or when they erupt. So, why are volcanoes important? When looking at a volcano in the moment, they are a major hazard, especially for those people living near them. If or when they erupt, they cause mass destruction, and a majority of the time they result in at least a few casualties. A little-known example of a volcanic eruption that caused massive damage and took many lives was Mount Pelée on the island of Martinique. In 1902, this eruption caused the death of 29,933 people with the lethal gases and hot ash that was an output of this eruption. However, when talking about long-term, studying the effects of the aftermath of volcanic eruptions sheds a different light on the importance of volcanoes. As a volcano erupts and the magma destroys vegetation that was once covered the dormant mountain, it leaves behind rich nutrients that help new vegetation to grow back, even more abundant than before. Volcanic ash can contain nutrients that are advantageous for plants in their regrowth. As well as aiding new vegetation, volcanoes are also important in adding to the atmosphere. The gases are released during a volcanic eruption contributes to replenishing our atmosphere as well as adding water to it, which helps contribute to the sustained level of our oceans and lakes. Now on to talking about the different styles of eruptions. When classifying eruptions, there are two main styles: fissure and vent. A fissure eruption is common where the crust is under extension and where the magma is relatively fluid. Fluid magma spatters up from the fissure in the crust. These types of eruptions are most commonly found in regions like the mid-oceanic ridges where Earth's crust is pulling apart and magma is conveyed upwards towards the central fracture of the crust. Fissure eruptions typically occur in a line formation, which usually don't include any explosive activity. Fissure eruptions are sometimes referred to as a curtain of fire. The second main style of volcanic eruption is a vent eruption. This kind of eruption occurs when magma is expelled through a central vent. Vent eruptions form different kinds of landforms, including shield, composite, and cinder cone volcanoes. Shield volcanoes have a broad structure with a gentle sloping, which makes a large, spread-out area that resembles the shield of a warrior. Hence the name a shield volcano. Composite volcanoes are named as they are because they are formed by the collection of magmas after multiple eruptions. These eruptions can occur hundreds of years apart or even thousands of years apart. Some well-known examples of composite volcanoes include Mount Fuji in Japan and Mount Rainier in Washington state. Cinder cone volcanoes are formed by compounded basaltic fragments. Gases carry liquid lava into the atmosphere, which when it returns to the earth, form a cone around the vent. These are the most common type of volcano according to San Diego State University. I now want to discuss a couple different types of magma that are generally associated with the different styles of eruptions. First, mafic magma can be associated with vent eruptions because it is less viscous and more fluid than felsic magmas. Because mafic magmas are fluid, they flow swiftly, which allows them to spread over large areas. As a result, the lava creeps outward, causing the large shield-shaped volcanoes previously mentioned. The second type of magma that I would like to talk about is felsic magma. The high viscosity or thickness of felsic magma creates more explosive reactions in volcanoes. Felsic magma is more commonly associated with fissure eruptions, which, as we kind of discussed earlier, are pretty rare. Felsic magmas seldom reach Earth's surface because it is so thick and moves so slowly, it often cools underground to form deposits of granite. When felsic magma does reach Earth's surface, its high concentrations of gases usually cause much more explosive effects than the following mafic magmas. Okay, so I've talked a little bit about different styles of eruptions and the different types of magmas that are associated with those, but what actually causes an eruption? A volcanic eruption is essentially the expulsion of magma and gases that are formed when the Earth's upper mantle and or lower crust subduct and melt. There are many different factors that could cause a volcano to erupt, the density of the magma being one. As written in the Scientific American Journal, if the density of the magma between the zone of its generation and the surface is less than that of the surrounding and overlying rocks, the magma reaches the surface and erupts. Another factor could be the subduction of more of the Earth's crust into an already full magma chamber, which would force some of the magma in the chamber to travel towards the surface, where it would then erupt. To start my conclusion, I want to talk a little bit about how scientists predict eruptions and the positive effects that these studies could have on many lives. Although technologies have improved since the first documentation of an eruption in 79 AD, volcanologists are still not able to predict a volcanic eruption with certain accuracy. Predicting volcanic eruptions are based on the history of the volcano and how well volcanologists believe they will continue to erupt in the future. For example, if a volcano erupted violently with lots of ash and mud flows in the past, then it is expected that it will do the same in a future eruption. Determining the exact time that a volcano will erupt means several things must be monitored. A few of these measurements are the seismic activity, ground deformations, and gas emissions. In 1991, a great example of the benefits of studying volcanoes and predicting when they might erupt took place in the Philippines. The U.S. Geological Survey predicted that the Pinatubo volcano in the Philippines would erupt June 15th. This accurate prediction allowed time for the evacuation of the area, saving thousands of lives. Finally, I have included some of my references that I used in getting all of the information for my presentation.